Going to do radicals, which I already told you guys are basically just exponents. And so real quick, if we have that, what would it be in exponential form?
That's a 5 over 3.
Okay, so is everyone happy with that?
Yeah.
So I covered them up with my screen, so I guess I'm going to rewrite these. These are some things to keep in mind, because mostly what we're doing is just simplifying. Okay, so let's see, how did I start it? Basically, like, here's the first thing. This is good notes. If you see a radical sign and you're asked to simplify, then factor key.
That's a radical something?
Huh?
I thought that was a square root.
Yeah, so the square root is a type of radical sign. So yeah, that is a square root. All right, so that's the first thing I want you to keep in mind. If you're ever asked to simplify, basically a radical, you're basically just doing a factor tree, okay? And then
Looks pretty sweet.
the blue looks good, doesn't it?
Yeah, can you see what's on there?
No, it just looks the same.
Oh.
Isn't that nice? It's pretty cool, man. You get a record and everything. Technology, you know what I'm saying?
Yeah, it's crazy.
Technology is great. That's called the index right there. And the index is basically telling you when you're simplifying, it's basically telling you the size of the group you're looking for. Uh-oh.
So for like
Uh-oh.
45, we have to factor tree it out. We just put down the answer.
Okay, so I'm gonna start on 46. No, you can just put down the answer, that's fine. But I'm gonna use it to explain, okay? All right, but that's basically what's going on. So we're gonna look at 46. Your assignment is 45 to 69 odd. I have no idea why I'm giving you guys such little work.
I like it. Just for a little
But yeah, I mean, yeah, I don't know why. But this is a lot of, like, there's still a lot going on. We need to know how to do this stuff, and we got to remember. So I'm just going to do 46 because it's easier to go through these and explain as we go. So I believe everyone probably knows the answer to this. 7. Okay, so here's how it works, and here's how I want you to think about it. Like I said in those first two things, you see one of these, you do a factor tree. So we're going to take 49 off to the side, and we got a 7 and a 7. Now the index up here, it's not there. So that means if it's not there, that means it's a 2. So then that's telling us that we're looking for groups of size 2. And sure enough, we have one group of 2 7s. One group of 2 7s. And that's why it's 7. Is that right?
Mm-hmm.
All right. So let's look at part B there. And you'll have plenty of time to work on this homework. So I'm a gentleman. Believe that, Ian?
Yeah.
Is his name Ian?
Yeah.
Yeah, it is.
He's a little swell.
It seems fine.
Took him one too many whiteboards to the head.
Whiteboard?
I showed that to my English teacher, that video, because that was my
Show it to him.
Oh, man.
Oh yeah, I got something to show you after we're done.
It was, it's interesting.
We'll finish this and then we'll show you the video.
Freshman year, wasn't it?
Yep.
It still sticks with you, huh?
Oh,
yeah.
there's no way it couldn't.
Alright, here we go. We're gonna do factor tree and a factor tree. Factor tree with 27,
3 and 9.
and then,
2, 3, not 3. So you have 3 groups of 3. Or no?
yeah, okay, well, so let's do this first. 2 and 4,
2, 2.
and then 2 and 2. Okay, and then what size groups are we looking for?
3.
3, and we know that because of the index. So here's one group, and so then this top becomes 3. And then here's one group, and that becomes a 2.
That's the answer?
That's the answer.
That's pretty simple.
I wouldn't make this harder than
Say
it
this
is.
now, but.
Alright, so looking down, what about 52 or 54? Do we want to do either any of those?
Let's just do 52.
Yeah, we'll go
52? 52? No, you guys are only doing odds. I'm doing evens.
An even, so you don't do
Yeah, I told this to the other class. I don't want to do all your work because then you won't get the pleasure of doing it yourself.
True.
But then you won't know anymore.
Then you'll just be the same person you were.
And then I will get better at math and you will not. And how sad is that? How sad is that? Answer the question.
It's pretty sad.
There's
Very
a
sad.
possible way to get
Very,
better
very
at
sad.
math than you already are.
Very sad is the correct answer. All right. So you guys know everything there is to know. I will say that as I said this on Friday, this is equivalent, just so you know, these two things are equivalent. And wait, hold on one second. And what I was saying before is that sometimes being on the left-hand side is going to be useful, and sometimes being on the right-hand side will be useful. And the only way you know which is most useful to you is to do more of these kinds of problems. So yes, what did you have?
I was going to ask you if we could square root first 100 and then you can put the exponent, do the exponent.
All right, so can we take the square root of 100?
Yeah.
What is it?
10.
So then we have 10 to the negative third.
Do you simplify or is that the answer?
That is not the answer. You never give me an answer with a negative exponent.
Now you gotta flip it the other way.
So that would be,
1 over 10 to the third.
and then we might as well just do 10 to the third.
3,000.
Is that right?
I skipped a step in there.
Where'd you get the 30 at?
All right.
To the power of 3? That's where you got it. I would have said 3,002.
And then we'll do this. We'll do 53B because I did it in the other class. Is that okay?
So what'd you say our homework was again tonight?
But it's 45 to 69 odd. I apologize.
No apologies needed, sir.
No, I do.
Right, most of these are B problems on par.
Can we do 49? Can we do?
Can we do this first?
Let's do this one and then we'll look at 49 too. That's fine. We'll do at least part 8. What is the other part of it?
Negative 2 or 5.
Negative 2 or 5. All right. What do you guys want to do? A lot of different ways you can start this one.
Well, so the negative 2 is it's not a square root, right? Because it's on the top.
That's right. That's squaring. Yeah. It's the fifth root on the outside thing.
So could you?
So a lot of different ways. And this can be frustrating to people, huh?
I don't know.
Because there's so many different ways you can start this. This can be a little frustrating. What were you saying?
I said, like, you know how you do the square root and then put the 2 on the outside, but that's not.
Why don't we just take the square root of 32 to get a smaller number there first?
We can do that, but so the only problem, like I'm going to tell you what the only problem with that is that the square root of 32 it doesn't have a perfect square.
It's gonna be a decimal.
Never mind.
So-
Let's ignore that.
So, well, I mean, that's a good idea, but like, it's not going to be as simple as you would think. Because, like, when I first looked at it, that's what I would have done. But
You could just factor it down.
And that's what he's saying. Like, we can do that. Do you guys want to do that? We can do it.
So we factor it out, it's gonna have
So well, let's find out. So 32 would be what?
8 and 4, right? 8, yeah, okay. And there's 4, 2 and 4, 2 and 2, 2 and 2. Oh, so there is 5 2, yes.
So the 4 on the outside.
Oops,
is
what
the
happened
square
there?
root.
There is 5 2s, but that doesn't work with the square root.
Yeah, so make 2 pairs.
Huh?
You have 2 pairs of 2s.
Yeah, so if we're doing that, then we have, so then this is what we do. And you can always say, well, I'd rather not do that, but this would be 4 square root of 2,
You have 2 groups.
right? And I don't know, maybe that's not as
So
nice.
that's just simplifying it, that's not solving it in any way.
Well, I mean, that's all we're doing is simplifying, so.
Is that the answer?
Oh, no, we're not done.
That's what I thought.
But the question is, if you want to continue on this pace, it's fine if you do. I mean.
We've already started.
Okay, all right, so now what then?
You've gotta flip that whole thing over to get rid of the negative.
All right, so that's a good place to be also. We can do that.
Put the entire thing over?
Well, it's gotta be 4 square root of 2 over 1, because you're just distributing the negative 2/5 though.
Well, okay, and so really you're only distributing the negative sign, right?
Yeah.
Yeah, so that's good, because you don't have to do it all at once. So now is it okay if we do this? Is this okay?
Yep.
That looks pretty good.
I don't know how to get rid of that.
Well, we're going one thing at a time.
Well, I mean, if you put up the 2, can't you get rid of the square root?
What is that 2 doing for you?
That's
It's like,
So so I'm going to write this. So really, this could be what it looks like. It could look like that. Because right, that denominator of 5 is your root. The 2 is just squaring. Does that help us, or is that a good place to be, or what do you guys want to do?
Yeah, I like that.
Yeah.
So if you're doing that, I would square that stuff first. What's that stuff become squared?
16 square root of 4.
Square root of 4, so
Just, oh, 16 and 16.
no. 16 times the square root of 4, but what's the square root of 4? 2, yeah. So then we're at the 5th root of 32. So then what?
Wait, where's the 16 come from?
Because we got to square everything, right? So we got to square this.
and there's a
Oh,
square root
jeez.
to it.
We got to square that. So that's squared and this is squared. That's at 16.
4 and then there's 4 inside another. Got it, makes sense.
All right, so this up here was the square root of, or that was 32 factor tree down. So 1, 2, 3, 4, 5. Now that's what size group we're looking for. So we got one group of 5 2s, and so that is just 2.
So the answer's 2.
So the answer is 2. Just like it.
Way to rank the number 2.
Can you just skip all that steps and just find out the answer is 2 from factoring down 32?
Well, so I guess
I mean, I'm just wondering.
the way I would have probably done this one is I would have, I probably would have done this negative 2 all at first. And then I would have gotten, yeah, I would have got, yeah, right. I would have just gotten 32 to the 1/5 right away.
Oh, yeah.
Yeah. That's how and then I would have broken down, then I would have done this stuff over here.
So basically, we just added 10 more steps.
Yeah, you added a little bit, but,
I knew we were doing way too much.
but,
Why does that change to 1/5?
Because he squared it.
yeah.
So now it's just 1/5 and not 2/5.
So, you guys are always like so concerned about the most efficient way to do it, but like, that's not a big deal. I mean, I've done way more of these than you have, and I know a lot more math than you do, so it's easier for me to identify the quickest way. But the important thing to understand is that there isn't only one way to do anything, and that it's better to start moving than to just stare at it wishing you could figure out the best way. Okay, so like, just because we went down here first, I mean, that's fine. We're moving, we're doing something, and it's getting more something that you can handle. So as long as you guys are, and this is, I'm going to say these types of things throughout this whole year. As long as you are doing true moves, then everything's fine, and you're going to get there eventually. Okay, and so efficiency is wonderful, but you know, there's other good things. So 49, you guys want to look at 49A real quick?
I just have a question about 53A. So if it's a -1,
Negative, if you have an exponent of negative,
1,
something, yes, something needs
so
flipped,
then
yeah.
it'd be +16.
Which one?
A. If I flipped it, it'd be 16 over 1, -16.
I don't know, which one are you looking at?
53A. Or 64.
Oh, yeah, so yeah, it's negative 64 to the positive 1/3?
Yeah.
Yeah. Alright, so A is gonna be another one of these ones that maybe you don't right away see what's going on. But the first thing that you should be looking at on this one is that negative sign inside the radical. And can you even do that? That's the first thing you should be asking. You're saying, yeah, what are you saying, yeah? So, okay, so right, yeah, so if you have an odd index, then a negative is fine. If an even index, you'd be like, no, you can't do this, right? So an odd index makes this fine. So the way I deal with these is I just say, I know my answer is going to be negative, and so then I would, like, in my head, I would just, like, I would do this. And then that way you don't have to, well, that's supposed to be a
Carry the
5.
negative sign all the way down.
Yeah, and so then the negative is going to be part of your answer, and now you just treat it like it's a positive. Is that?
Couldn't you just like get rid of the exponent on the outside so that it gets rid of this cube root?
So then what he's saying is what if we wrote this in the other form? Right? It's in radical form. Let's write it in exponential form. So it's 3 over 3, which reduces to
1 over 1.
1 over 1. And so then really we're just down at negative 125.
That's the answer.
And that's the answer, yeah.
It doesn't matter because cube root it, you down -5, you said.
Well, it does matter right away, though, because can you even have a negative in there? So that does matter.
Yeah.
Yeah, okay. But, you know, if you were here and you didn't recognize that you could do that, then you just do your factor tree, look for groups of 3, then cube your answer, and you're still fine. Okay, so again, just because someone is doing it differently doesn't mean one of you is wrong. It's okay.
What number was that one?
That was 49A.
How did you just pull the, index out of the brackets like that? Wouldn't you have had to change it to like 125 over 1/3, and then?
And then you get 5 root of 5.
So, yeah, so like, I think
125 to the 1/3.
so you could, like, if you want to see it written out, it'd be like negative 125
You factor it down.
to the 1/3, but it's still being cubed.
Yeah.
And so then if you're doing this,
125 divided by 25.
then what you're saying is like, okay, I got
3 root of 5, 5 root of
a power to a power. And so that means I multiply my exponents and then you're up to here. Yeah, and that's fine too. Yeah, however you need to think about it is good. All right, we okay? All right, I'm only going to do like maybe 1 or 2 more. So we're looking at, let's look at 64, no, let's do,
So for 65,
62A.
65 would it just be 5 to the 5 and 12 over 9?
Close, but that's not how you add.
How many are you supposed to do? From what?
69. He's saying something, but that's not how you add fractions. I mean, you're almost right. I'm doing 62A.
I'm almost right.
You're almost right, but you didn't add your fractions very well.
It's supposed to be 5 to 12 over 6.
No, that's not how you add fractions. How do you add fractions?
I don't know, multiply?
Oh, no.
That seems like a weird answer. If I ask you how to add them, you said multiply? If you have, no, that's how you multiply, you go
If you had
straight up.
counted none.
Then you just add the numerators.
Oh, so it'd
You
be
lose,
12 over 3,
yeah, which reduces to,
4.
yeah.
That's why you said it.
Alright, one more for me. What are you doing this one?
Did you change it to the,
You put y squared on the outside.
the other form?
So you can either mess with that, but either way, what do we have to do with the 54?
Get away from the exponential.
Well,
Way
by
to
doing,
square
but,
root it.
well, there is no square root of 54. So,
Factor it out.
yeah, so let's factor a tree it. So what's that go to?
699. 3 and 2.
What size groups are we looking for? 2.
So 9 is on the outside, 6.
No, not a 9. 3. Why is it 3? Because one group of 3, so that 1 comes out, so it's 3.
6 is on the inside.
Yeah, the 6 stays on the inside, correct?
You can take out the y to the 4th power and make that y squared.
Yeah, so how does it, yeah, so, now it all depends on where you're looking. Like if you're looking over here, this is a power to a power, so 4 times 1/2 is 2. No fraction, right? No denominator, so that came out as y squared. Right? Or you can look at it here and say, I need group sizes of 2, and I have 4 y's. And so then there's one group, there's my second group, 2 groups of y's. Is that okay?
What happened to 6?
Well, we're not done yet, but just this part, is it,
Outside square root.
is 3y squared okay so far? And so now, everything that didn't get grouped up, any questions on that?
That's an answer.
We have a couple of, yeah, we have people not sure.
Is the 3 because it did not end up in a group?
This 3
Yes.
is from this group. We got one group of 2 3s.
And the 6 is because there's not another 3 in it.
Yeah, the 6 is because these two didn't have a group to come out with, right? There was not 2 2s or 2 more 3s. And so they came inside and you multiply them 2 and 3. Right, and then we got all the y's came out. You know, again, or if you're looking here, 4 times 1/2 is 2. How's that?
Makes sense.
Is that good enough? We're ready to go? Can we do the rest?
Yeah.
Ready to start? Alright. What's up?